The last hydrocarbon that we need to talk about before we move on to other compounds are aromatic hydrocarbons. The main thing about aromatic hydrocarbons, we might think that they're going to behave as if they have double bonds, because they do. But throughout the last couple of units, I've been talking about how the benzene ring is very stable because of the delocalized pi bonds. And that makes them unreactive. They actually don't undergo addition reactions. You can't just add molecules like we just saw to the benzene ring. It's too strong. Yep. Yeah. You can substitute them. You can do a substitution, like as if it's an alkane, but you can't do an addition reaction. So what we're seeing here is an example of halogenation, an addition reaction of the benzene ring with bromine, and it will actually do this twice. So I'm going to put here a 2. And in the end, we end up again with 2, in this case, HBr. It's not that each bromine gets added in, right? An H comes off and makes an HBr. Yep. They actually will always go in the pair, what do we got here? Meta position. So in this case, we do want the meta position. Meta position is favorable. So the favored product, 1,3, what we're really saying here is meta is favorable. Memorize it. Now there are other things that you can add readily to a benzene ring. And the next one is a nitro group. So you can actually react nitric acid with a benzene ring. And I'm going to show you as soon as my pen starts working again. The reason we're writing it in this way is because what happens is an OH, this molecule looks like this. Actually, we had this molecule on our last test, right? That's what I wanted you to draw the Lewis structure for, right? Now, I don't have all the electrons in there, but there's obviously a structure there. And this structure actually has a resonance scenario that looks like this. Actually, I will draw the rest of the electrons in. It has a resonance situation that exists between these two O's. I can put the double bond to the other one. What happens is that OH falls off, okay? And it becomes a water because it plucks off one of these. And it gives us this situation here. And I'm going to add 2 of them to it. What am I doing with my benzene ring? That's a horrendous benzene, but anyway, you get the idea. Put a double bond there, put a double bond there, put a double bond there. And you end up with an N, yeah, it's a sad one. Yeah, it's a sad benzene. You end up with an NO2 over there, and you also end up with an NO2 over there. And actually, the resonance of this NO2 feeds into the benzene ring. It actually, the delocalized pi bond goes all the way out into the N's and the O's as well. It actually makes it stronger. Anyway, this is nitro. So that group here is nitro. That's called a nitro group. It's going to be 2. So what do we have left as our other product? Oh, sorry, 2, yeah. This is also 2H2O, okay? And the name of this is meta-dinitrobenzene, or 1,3-dinitrobenzene. 1,3-dinitrobenzene. All right? 1,3-dinitrobenzene. Okay, the final reaction for aromatics is called an alkylation. And in an alkylation, we want to take the alkyl group, and we start with an alkyl halide, and we want to add that alkyl group to the benzene ring. And this reaction, again, is very much like the previous two reactions we've seen. We're going to have a removal of an H. Again, it's a substitution reaction, and we're going to have the alkyl group go in there. I didn't mention this in the previous examples, but in these particular reactions, a catalyst is needed. Let's not worry about what the catalyst is, but we do need a catalyst in order to initiate this reaction. But once we've done it, we will have our benzene ring. And I've rotated the benzene ring. I apologize for that. It's not a big deal. Again, alternating double bonds. And now in the position of one of those H's, we have a methyl group. All right, so we end up with methylbenzene. And then we have H's on all the rest of these, and I'm not going to draw it in. And because we had an H removed and we now have a Cl left, we have HCl as the final product. All right, so that is the final reaction that goes along with reactions of aromatic compounds.